Okay, so this is my setup. I have SolidWorks up here. I have a spreadsheet with my own naming system down here. And I have a bunch of, I'll go through them real quick, a bunch of reference images that I used to design this engine, even though it's already a real engine. So this is based off the IAE V2500, which is used in the Airbus A320 family. And I made this sketch. This is my initial sketch, and based off of this image right here, not this one. And I had to make the internal shape of it, and just give myself like a gauge of how big this is gonna be, and how big each stage of compression is gonna be. So on SolidWorks, I had to design each part. So the first, first difficult part I designed was this fan blade. And I had to make 4 different planes to design this one. And basically I used a loft feature, which connects as many images, as many sketches as you want on as many planes as you want. So I had 4 sketches on 4 different planes, and that's how I got this shape. The shape of this, and this bottom part is just to put it in this housing I made right here. So each one of these can come out. They're kind of stuck in there though. Maybe this one, yeah. This is the singular, blade. I'm gonna stick it right in there, and this is already one big part of the engine that is done. How did I come up with the amount of blades to put on each one of these pieces? Well, the internet doesn't have a lot of information about, specific information about this engine. I only knew that this front main fan has 22 of these blades, so I had to print 22 of these. It took like 5 hours, which was a long time. It was one of my first prints, and it was kind of a big step, but now it doesn't seem as bad compared to the other parts I printed after this. So I had to count for the rotors and the stators. I had to count off of this image. This is a model of the V2500, and I saw that this was a quarter of the engine, so I counted all these blades and multiplied it by 4 for each stage, and I came up with 72 for the first rotor right here, and it goes from 72 to 80 to 92 to 100. So, it might not be 100% accurate, but with what I had, this is the best I can do. Within here, I had to design a gearbox because this whole front part spins at a different speed from this middle high compression part. So they both spin in the same direction, but I had to figure out a way to, have them spin at different speeds while also being connected. So what I did for this was I made a planetary gear set. So I have the planet gears and the sun gear, and I made a ring gear that goes around. You'll see me put this together when I assemble this. And this is the part on CAD that I designed. This part fits into the main fan section, and the planet gears go on these 3 posts, and the sun gear goes around the middle, and this is the low compression shaft that spins within the high compression shaft. This is the first stator, which is right here. This is the part I designed, and I made a drawing on SolidWorks with, I added the dimensions with this tool right here. This is radius of 29 millimeters, and it allows you to make the sketch and print it out. So I have like a bunch of them right here, and basically this is really good because I use the dimensions from one part to make the next part to make the next part, and to design this thing as a whole, to make sure everything fits together correctly. Next, I'll go over my assembly process of the first section of this engine, and I think it'll make more sense once you see how all these parts fit together.